stand-in. It's good to see Aaron Brown here, but this is a little tough because, as you see up there, acknowledge my co-authors, Michael Connerton, who is here, excitedly, and Jeremy Holden, who is not. We've learned a lot of new things in our Prayfish program over the past couple of years, and just about all of that has been due to a collaborative approach. We've really tried to expand and rethink what we've been doing, and not just coming from one piece or one entity, but thinking about all the different groups, all the partners and stakeholders, the information they're looking for, and figuring out how we can adjust our surveys, maintain the consistency, but provide better information. Quick acknowledgement of the funding sources, because it is collaborative. There's a variety of different institutions contributing to it, including a thank you to a huge number of support staff, vessel staff, administrators who keep the money flowing, administrative assistants who keep us out of trouble, and all those sorts of things. So none of this is possible without all of their help. You heard Chris mention and others mention the fish community objective. Certainly that's sort of the guiding document for the information we're trying to provide. But there's also some other supplementary information sources, things like our USGS ecosystem strategy document that talks a lot about understanding drivers of these systems in the places we work, as well as some outside review that we had done at that time about 15 years ago, but still incredibly relevant to the work we're doing today as we look to improve. Another one, you might see this in some other talks. This is sort of an adaptive framework for corriganine restoration across the basin. Our Center Director Russ Strax often talking about this. He'll talk about a couple pieces of it. One of the pieces we're really working on is sort of the gap analysis and understanding what we have in our contemporary populations. Some other folks here are working on some of the historical stuff as well. The improvements we're making come in a variety of different forms. One of them is understanding seasonal changes and catchability. Here showing two of our different species since we survey both in the spring and fall, we actually see drastically different results. And so you can imagine if you're trying to assess and inform diversity indicators and you used only one of those surveys, how different an interpretation you might make about a species depending on when you assessed it. Space and thinking about really how good a job we're doing. We always sampled where we sampled because that's where we sampled. But one of it was a review of a paper by John Jansen, and he basically said, what are your biggest misses? What have you been screwing up? And one of those pieces was that sampling just where we always did. And so we've been trying to rapidly expand and experiment with sampling more diverse and different habitats and seeing what information that provides. Finally, collaboration. That's something we've already learned has been critical, but we can always do better. A big thank you to Mike Gailey and Dmitry Gorski of the Fish and Wildlife Service, the BASIM office. When we didn't have the staffing to cover our Prayfish survey last fall, they stepped up and got people that were able to go into Canada and work on our boat and allowed us to complete that survey. So we're looking forward to potentially collaborating with them more in the large boat program. And then really thinking about those drivers, we're constantly thinking about the larger context of our Prayfish surveys and our assessments, thinking about temperature change. Certainly we're seeing what many would consider a fairly rapid change in the temperature, about a degree Celsius for every 25 to 30 years. Similarly, decline in mineral nutrient input. Phosphorus concentrations show a very strong relationship with our total prayfish biomass. And so as we put these together and thinking about trying to inform decision makers about the resilience of the system, these are the things we're thinking about, and also any future invaders that are potentially out there, not just surveilling for them, but considering their potential impact. As I mentioned, our surveys here are conducted by 3 boats, the DEC, OMNRF, and our USGS vessel. We do 2 surveys, one in April. Last year we did about 200 bottom trawls for that, and 100 in the fall. We also do an acoustic survey, which for time we're just not going to be talking about, but please check out both the DEC and OMNRF's annual reports, which detail all of these results and more. You can see the map there about where we're sampling, an example of where we're trying to get into new places with these whole lake surveys is getting into these different embayment habitats. So, sort of acknowledging the elephant in the room, there's been a lot of changes that the fish managers have had to make with regards to stocking levels in response to changes in the prey fish community. These are just a couple headlines. I love the DEC remains steadfast despite criticism. For those of you who work in that arena, the criticism is the one part that is never really ends. And we just got done with a big public tour and outreach for stakeholders, and it's always interesting to see, no matter how many fish people can catch, they can still be unhappy and want more. So really there in the lower right-hand corner are some alewife, and that's the primary prey fish that we're talking about in our spring survey. Here I'm going to show the adult alewife biomass time series. If you look in the reports, you'll see things reported in number per 10 minute of trawl. I switched back over to a biomass for this audience. We try to keep our reports standardized. Switched over to a biomass simply because it helps us think about differences across lakes. First thing to point out is we've only now started a whole lake program. We've had that for 3 years, Previously, it was only a U.S. waters survey. What you see on the far right of the figure is since we've started that survey, we've learned that a lot of that annual variability that we couldn't attribute to factors such as sampling, predation, or recruitment actually had to do simply with distribution. Some years there were more fish in Canada when we took that survey. Other years there were more fish in New York. And so that really, in its inception, highlighted the importance of this whole lake program. I put this on this scale as well. The lake's basically 50-50, US and Canada, so you can imagine a whole lake number really just falls in between those 2 points. And so in 2018, we did see a slight increase. We expected that. We knew we had a big year class coming through, but certainly it helps you understand sort of the decline and the predicament that managers are in right now. I also, if you've ever seen this figure before, back in the day, a decade ago, you would see people converting these numbers back to historic numbers. Now we're actually converting the historic numbers to the current numbers. And what that does is just give us a better sense for the overall fish biomass in the lake. So for people that think about sort of the ecosystem ecology of this system, it really helps to put them in those terms. We assess alewife after their first year of life. So in the spring, when they're age 1 fish, it's our indicator of year class strength. A couple things to point out here is we see that similar pattern where the US and Canadian numbers are not, waters in US and Canadian are not the same. For instance, we saw this great, what we thought was 2016 year class in the US, but the numbers were much lower in Canada. In 2018, we did not see much of a year class. And then highlighting sort of what got all this started, those cold years in 2013 and 2014, we saw pretty much back-to-back very poor year classes. In fact, that year class was the lowest we observed on record. So this is sort of setting the stage for having a low number of adults, having reduced recruitment in the future, and this is why Andy and Steve and others acted the way they did with stocking cuts. Another piece that plays into this as we sort of move off into more of a predator-prey dynamics and understanding sort of the ratio of predator and prey is recognizing how the prey fish community is changing and simply their growth, or their, in this case, mean weighted age. For the first 20 years or so of the program, the mean weighted age here showed for each different ages and colors stayed relatively constant, fluctuated somewhat. But more recently, we've seen that those dynamics change drastically to the point where a 3-year-old alewife in 2010 weighed as much as an 8-year-old alewife used to weigh. So you can think about if you're trying to fill the belly of sport fish while continuing to have enough biomass out there to have successful recruitment, these things change when we start seeing growth differences of this magnitude. When we wanted to try to understand sort of what helped explain that variability, we looked at 4 things really: biomass of alewife, zooplankton from the epilimnion, temperature, and yet what fell out most importantly, or what fell out most starkly, was the biomass of predatory cladocerans. This is the Bythotrephes and Cercopagus. And so where some of the first predictions were that they potentially would cause detriment to prey fish and growth, they've actually caused the opposite. They've resulted in a longer growing season and a larger food item for alewife to consume. The best models was actually alewife biomass and Cercopagus in terms of explaining the dynamics that we see in alewife. We've put these things together to try to, we have whole lake estimates now, not very many and not for very many years, but we have some growth estimates. So we've been putting these together, trying to predict alewife biomass and its change, get into a predictive model and comparing our observations to predictions, much like Dr. Bentz talked about, but in a much simpler sense in this case, where we're just moving 1 year at a time, using our 2016 data, predicting our 2017, and observing where our observations were either correct or not. These predictions are just Monte Carlo simulations of possible outcomes for that year, taking into account the differences we see in survival and growth. We do that again from 2017 to 2018. We predicted a much larger increase in biomass. We didn't see that, and we can kind of step into any one of these years and try to understand where our predictions were off. And in this case, the predictions were in these 2-year-old fish where we predicted a much higher biomass. There were fewer of them, and they actually grew less well than we predicted. So combined, that caused our predictions to be much higher than what we actually observed. And finally, when we're thinking about sort of how age structure is influencing the population, there was often some disagreement about when do these fish start contributing back to the population. The literature said anywhere from 2 up to 4 years of age, and that really matters when you think from a decision making in terms of figuring out how quick you have to respond to changes. And so one of the pieces is we started looking at age 2 fish and the reproductive capacity of those. I'm not going to embarrass myself by explaining a lot of Dr. Rincard and Tom Bianchi's work here, but you can basically understand that if you examine an alewife ovary and it's in the blue stage, it's not mature, and then it moves through to get to that yellow stage. When we look at age 2 alewife across an entire year, what we see is they are indeed maturing, and they're at some different stages, such that this supports the idea where we do see these fish having possibly multiple spawning, or at least contributing to a protracted spawning, that's really kind of extending anywhere between late June all the way into August. So thinking about a lot of neat things with that. But I'm going to quickly switch gears here, watching my time. Thinking about the basin-wide effort to understand and restore corriganines, where these prey fish assessments can come in, is defining their historical or really contemporary populations. This is some work that's in review where we used our trawls and just asked, where are we picking up cisco? How similar are they across these different regions? Folks know, and as others have said, really this eastern basin of Lake Ontario, including the Bay of Quinte, Chameau Bay, and a bunch of bays here, is a well-known sort of hotspot. Spawning areas have been documented there, and the population has trended there in our trawls with some increases recently that have been on the same magnitude of what we saw in the late 80s and early 90s. But just as importantly, while we saw them there, we also saw them in places like Sodus Bay. And you'll hear more about this from Jim McKenna, but There's some ongoing restoration efforts there, and it makes us wonder, is sort of like, is what we're seeing now in some of these other places around the lake, is this really a remnant populations, distinct populations, or is this simply spread out of that Eastern Basin refuge? So those are some of the questions and hypotheses that we're trying to address. We addressed that, thankfully, with a large influx of CSMI money. I have to thank Todd Nettesheim and EPA and the whole CSMI process, and a lot of folks in this room. Incredible collaboration to collect something like 1,300 larval samples over a 3-week period to understand larval carrageenan. And here I'm saying carrageenan because we're still working on identifications between ciscos and whitefish, but we had folks sampling all over, including Toronto, Hamilton Harbor. We did catch a larval carrageenan in Toronto, which is exciting, but lots of folks, lots of different regional state folks, OMNRF, Queen's University, a lot of different people contributing to that. Certainly sort of the true C portion of CSMI. We're also then using these surveys to map adults and juveniles as well. Here, this is the 2018 figure that I think Aaron and Jeremy made up for their report showing where we caught ciscos in all the different lake-wide surveys. Good sort of note of excitement, we caught 4 bloater in 2018. I'm probably emailed or texted half of you to make sure what I was looking at was a bloater, because I look at more alewife. We caught 3 alewife in the spring of 2018 out here by the Niagara River and by Hamlin Beach when the stocking site was here that previous fall. So, you know, interesting in its sense. The restoration started in 2012. We also caught one here in the fall of 2018. That's a picture of the fall fish. What was neat about that is a female with eggs caught actually in the same place the only other bloater was caught in our trawl surveys in 1983. So not a lot of data, but we're holding on to whatever we have. Is this surprising? A couple folks wondered, really, you're already catching them? And so to understand this, we just put together a little simple exercise to ask how many bloater would have to be in the lake for us to expect to catch one. We used our estimates of alewife and rainbow smelt abundance and compared that to how many we actually handled on the deck. And we found out that number was somewhere around, have to handle about 6,000 fish to detect one. Here, this shows the data for alewife and smelt and the percentage or proportion, that divided by 100. And so we have some at least estimate, ballpark estimate for what that is. We can also kind of step through how many are in the lake. We assume probably pretty low survival right after stocking, and then use some published literature values for survival after that. We know what we stocked, how many would be available. We can use that proportion to say how many we would expect to catch. And as it turns out, what we've actually caught is probably not that far off. You know, these are some numbers that honestly we're just grasping, but they're numbers from which to get better at. They give us a starting point. This is all U.S. waters. There are Canadian fish. Those aren't figured in here yet. We did it on a smaller scale first. Deep water sculpin. If you've been following this, this is kind of a neat story where deep water sculpin were thought to be extirpated for 30-some years from Lake Ontario. They now are the #1 or #2, depending on the year, most abundant benthic demersal species in the lake. We see some incredible, this is the biomass index that's lake-wide, and so they're just at incredibly high densities offshore. We're always wondering how long could that increase go? Well, it turns out till last year we actually saw our first decline, and we actually saw quite a few dead fish in our trawls. About a quarter of the fish that we caught deep water sculpin in had dead fish from across a wide size range. None of them were moribund. They were all cheesers. We couldn't get them in for testing, but we have been noting that condition has been declining. We've been comparing this to Lake Superior, and we do see obvious declines in condition, which you would expect at probably the densities we see. So with that, I will wrap up. It looks like I have no time for questions, but, oh, okay, there we go.